Hey, this is Mr. Warden. This is the video Do Now key for Algebra Do Now 26.2. And here we have a race between these two giraffes. This one is Bobbert, and this is Petrovich. Petrovich is a little shorter. But Bobbert starts walking north at a constant rate of 8 meters per second, after which another giraffe, which we will name Petrovich, also starts walking north at a constant rate of 8 meters per second. Bobbert starts 30 meters north of the hippo wallowing hole. And I'll show you the hippo wallowing hole now. Of course, there's the hippo wallowing hole. It's a very relaxing place to be. Okay, so Bobbert started 30 meters north of the hippo wallowing hole, and Petrovich started 24 meters north. Okay, so here we go. This is going to be Bobbert. Bobbert's equation is going to be, and so this is a rate and a starting point. So this is a great slope-intercept form situation. Y equals 8x plus 30. So 8 meters per second plus 30 meters starting place. Okay, and then Petrovich's equation is y equals 8x plus 24. Cool, we got our equations. So if that's what you came up with, 8x plus 30 for Bobbert and y equals 8x plus 24 for Petrovich, that will work well. So let's go to Desmos and do the thing. So I've got y equals 8x plus 30. We're going to see where they intersect. I'm going to go up here. So we're above the 30 line. So that's the y-intercept right there. And then we'll put in y equals 8x plus 24. Okay, where are they going to intersect? 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 They don't seem to be getting any closer to each other ever. In fact, they won't, because they have the same slope. And since they have the same slope, they are parallel to each other. So because they're parallel, they will never intersect. There is no place on this line anywhere forever where these two lines will intersect. You can keep going forever into the trillions, into the quadrillions, the quintillions, on to the end of time, and they will not intersect. So, no intersection, huh? Okay, they never intersect because they are parallel. Same slope, parallel lines. Okay, they're not the same line because they have different y-intercepts. So if they have different y-intercepts and they have the same slope, they're just going to go along forever next to each other. So there are no points that are solutions that make all parts of this system true. So no solution. Okay, let's take a look. One more time, enjoying that relaxing mud hole. And here we're gonna take a different approach to this. We substitute 8x plus 24. So this 8x plus 24 for this y, and y equals 8x plus 30. So since we want to know when x and y will be the same in each equation, we can assume the y's are the same, and we can replace y and y equals 8x plus 24 with 8x plus 30. So there we go. I said that backwards earlier, but that's what we're going to do. It doesn't matter which way it goes. 8x plus 30 can equal 8x plus 24. So now we're going to solve for one variable. So we've got 8x plus 30 equals 8x. Hopefully this looks sus to you already. So 8x plus 30 equals 8x plus 24. I'll subtract 8x from both sides so I can get rid of the 8x on the right. And then I end up with 30 equals 24. False. Fake news, false statement. Okay, since it's a false statement, since the variables disappeared, and we got a false statement, we have no solution. Okay, and you saw it in the graph. There was no way to find an xy value where they were both where that was true for both equations. So there is no solution to this system. And those are the two basic ways you can determine that. And, what you can look for is, of course, do these equations have the same slope? If they do, they're either parallel or the same line. And then do they have the same y-intercept? They do not. If they don't have the same y-intercept and they have the same slope, they are parallel lines. They will never touch.